It's 3 a.m. in a Seattle data center. An engineer doing routine maintenance stops dead. A sound cuts through the hum of 1,000 machines. Click, click, click. It's rhythmic, precise, almost deliberate. Most people would miss it completely. But this engineer knows exactly what it means. Their hard drive is dying. Not next week. Not in a few days. Right now, in this moment, data is starting to slip away. That clicking sound? It's the read-write head crashing against the platter. Tiny, repeated collisions happening dozens of times per second. It's the mechanical sound of a catastrophic failure unfolding in real time. And in a data center, when one drive screams, everyone listens. Because what happens to one machine cascades across the entire system. This story starts with sound, but it's really about survival. A hard drive is a miracle of mechanical engineering. The platter spins at 7,200 rotations per minute. That's like a vinyl record on speed. The read-write head floats on air, just nanometers above the surface. It never touches. The actuator arm zips back and forth, seeking data across the spinning disk. All of this happens in a sealed metal chamber. And all of this movement creates vibration. The platter spin produces a low hum. The arm's rapid seeking creates a clicking whir. The airflow needed to cool everything becomes background noise. In a single drive, it's almost musical. In a data center with thousands of them, all seeking simultaneously, all spinning, all cooling, that's when the noise becomes something else. That's when you can hear the system working. Hear it surviving. So what does failure sound like? There's the click of death, most famous of all. A read-write head smashing into the platter, over and over. Click, click, click. It's almost rhythmic, almost musical in the worst way. Then there's thermal beeping. A drive overheating will cry out in urgent electronic chirps. It's the drive's last warning, like a smoke alarm in slow motion. Ignore it, and you won't hear anything for much longer. The third sound is rarer but unmistakable. A high-pitched whine. The spindle bearing is failing. Metal on metal friction climbing. It climbs and climbs until the bearing collapses entirely. When that happens, the platter stops dead. The data dies with it. Each sound tells a story. Click means mechanical failure. Beep means thermal catastrophe. Whine means your drive is living its final seconds. Data centers are full of drives waiting to tell these stories. Engineers started noticing patterns. A clicking drive meant the read-write head was stuck. A grinding sound? Platter degradation. Within months, veterans could diagnose a failing drive in seconds, just by listening. The really sharp teams deployed microphones inside server racks. They'd record acoustic signatures, create baselines for each drive model. When a new sound appeared, algorithms would flag it immediately. No human needed to press an ear to metal anymore. Google published data. Acoustic precursors appeared 8 to 10 days before complete failure. 8 to 10 days to move critical data, swap the drive, prevent cascade failures. This changed everything. Failures weren't random disasters anymore. They were telegraphed events, readable to anyone who'd learned the language. The drives were screaming their death sentences. Engineers had finally learned how to listen. But listening creates cascades. One screaming drive isn't a solo failure. Modern data centers run on redundancy, backup drives, backup systems, failover servers everywhere. That acoustic signature triggers monitoring software instantly. Alerts fire. Dashboards go red. Engineers get paged at 3 a.m. In massive operations, Netflix, banking platforms, cloud providers, one failing drive can trigger massive cascades. Diagnostic checks fire across thousands of machines. The system starts asking critical questions. Is this correlated failure? Will other drives follow? Some data centers have documented a single drive's acoustic death triggering cascades through entire racks. Monitoring systems become overwhelmed. It's like one person screaming in a crowded theater. Suddenly everyone tries to listen at once. The infrastructure wasn't engineered for failure amplification through acoustic signals. One drive's death becomes many systems awakening. An engineer's phone buzzes at 2 a.m. A single acoustic signature triggers an alert. Within minutes, they're running diagnostics, watching patterns cascade across dozens of racks. One failed drive means imminent stress on replicas. The clock is ticking. Data centers are humming cathedrals built on redundancy. But redundancy isn't invulnerability. It's a safety net, Frang. When multiple drives start singing their death songs simultaneously, engineers face a choice. Replace them tonight, or gamble the whole array survives until morning. This is the acoustic reality most of us never encounter. The digital infrastructure humming in vast climate-controlled rooms depends on small teams listening. Not to music. To disaster approaching. Those sounds we heard, the clicking, the whining, they're not just mechanical failures. They're early warning systems. They only work if someone's paying attention. Netflix, emails, cloud saves, all depend on engineers trained to hear trouble approaching.